Everybody, this is Lori with the Virtual Jug. We are here today to have a fun day. Everybody that is in their own little lockdown. Hopefully it's not too terrible. So this is me. Actually, no, it's not. This is my daughter and she is in the other room. So everybody cross your fingers that she stays there. I work for JFrog. I'm a community advocacy manager, DevRel, and just really happy to be part of VJug. This is my first session, so I apologize for screwing it up in advance. So today, if you want to have a question, go ahead to our VJug Slack and use the live session channel and chat in your question there. If you have feedback, you can use our Twitter handle at VirtualJug, or go ahead and hit up Oleg because I am not going to handle anything. Haha, Oleg. So why are we here? We are here today because Andres Almiray is going to tell us all the things he wished he knew about Maven years ago. So let me go ahead, stop sharing my screen and hand it over to Andres.
Oh, hi, Lori. Hi, Oleg, and everybody else. Thank you for joining. Yeah, thank you for that introduction. So I'm hoping that you're going to have a really good time today. So let me remind you that you can ask questions at any time. We'll have myself and Oleg and Lori trying to answer them as quick as we can. We also have different options for you. If you're on the Slack channel, there's a live session channel where you can ask the questions directly. I think that we can also ask them on YouTube if you're watching over YouTube. So with that, let me share my screen and let's begin with the slides. And let's click play on this thing. And I hope that now you can see the slides. So, okay, the title today is What I Wish I Knew About Maven Years Ago. My name is Andres Almiray. I work for Oracle. I love open source and I believe in open source. And so I started like close to 10 years ago, open source program or a group called Hackergarten, which is a group of people that come together at the end of a working day and they hack on anything that is open source for a couple of hours. We have pizza, we drink beer, so we have snacks, and we have a really good time, and we contribute to an open source project of our choosing. Now, some of the things that we have contributed in the past have mostly been related to the Java community. Some of those have been plugins for Maven, for Gradle, or any other frameworks. So it's, if you see an opportunity to come together and hack on open source, then I will certainly recommend you to take that chance. Now, so many years ago, let's start with the topic proper. When Java was created and made public back in 1995, we didn't have any build system. We only had the compiler. And coming from C and C++, where Java was the emerging language platform, the first projects decided to use Make for building, because that's the same thing as C and C++ had at the time. And while that proved out to be okay for a while, it actually didn't work in the end, given that Make was not native per se to the Java platform. So a new tool emerged, and that came out to be Ant. It allowed you to build all kinds of things. You had a lot of flexibility. You had to use XML for the declaration. And for a while, things were fine. But as projects grew in complexity, the tool wasn't good enough. So a few cycles later, we got the first iteration of Maven. And that gave us additional features such as dependency resolution, a common application structure or file structure, plugins, and the convention of a configuration. And that things were fine, okay, until around 2007, 2008, that a new tool emerged, which is called Gradle. And the reason for this tool to exist is that the creator saw that while Maven was much better than Maven, it was very strict in certain aspects, and they wanted more flexibility. And they kept adding more and more features. And this is about the time, when this 2008, when I jumped to this from Maven to Gradle. And Maven, that time was Maven version 2, which was okay. But later in 2010, Maven 3 came out and added a lot of new features. And I have to confess that this is a time where I completely lost most of the things that you could do with Maven. I got so infatuated with what Gradle allows you to do that I didn't come back to Maven until just recently when I saw, well, is there anything that I have learned by using the other projects, the other tools, that might be missing or that might also be similar or might be better in the other ones? So with that, ladies and gentlemen, that's why I decided to come back to Maven and see what is there in Maven 3 and what may be upcoming in Maven 4 that will make your life much easier if you decide to use Maven as your build tool of choice. So one of the things I learned is, well, of course, you can have project properties. You can define properties in your POM files, but also you can have properties coming from plugins. Now, I must say that some of the features that we're going to discuss today may be obvious to you because you may use it every day. Some of these features may be completely new. And so I expect that we have people coming from different levels of expertise with the tool. So again, please feel free to just ask questions whenever you have. So in the case of defining properties, actually, I do have a type on this slide. It's not -b, it's -d for defining a property. -p is for enabling a profile in Maven. -p is for enable a property in Gradle. You can see that I still have a few things in my mind when it comes to the other build tool. Regardless of this, you can define properties whether inside a properties block in your POM files. It could be in a specific POM file, it could be in a parent, it could be anywhere in the hierarchy, or it could be provided by a plugin. Now, doesn't matter how you define the property. You can override the value if you define it in the command line. Now, let me show you a quick demo about this one. So I'm going to jump into the terminal. And I do have a simple project here. If I'm not mistaken, it's called properties. Maybe make it a little font a little bit bigger. And this particular project, I'm going to show the POM file. It's very basic. It contains the Maven coordinates, acme, the artifact name sample, and some version. So these are known in the short notation as GAP coordinates. GAP stands for group ID, artifact ID, and version. And it has just one dependency so that we can compile. Now, this particular code, I think it may have an executable application. So it's this sample class, and the only thing that it has is a simple hello world and prints out something. All right. So what can we do with this? Well, first thing, let's see that I don't have it in here. Yes, I'm going to clean, just so you know that nothing funny is going here. So here's my project empty. And let's ask Maven which version I'm currently using. I also will tell me which version of Java I have. So in this case, it's the latest version of Maven, 3.6.3. I'm using Java version 1.8, update 191, which is not the latest version of 1.8. That is actually, I think, it's either 2.3.4 or no, 2.2.2 or 2.4.2 at this time of recording. And regardless of that, we are targeting Java 8. So that means that if I compile my code here, just invoking Maven compile, I will expect the compiled code to be Java 8 compatible, isn't it? So let's figure it out. I can decompile the classes using Java P minus P minus V, and let's find a class inside acme sample, and let's look at the first lines of code, and it says major version 49. Now, I don't know about you, but major version 49 is not Java 8. That's actually Java 5. What's going on? We saw that I have selected Java 8. Well, so it happens that Maven, by the nature of its conventions and how it inherits its properties coming all the way from the top from the super POM, default settings for Maven compiler is Java 5. Doesn't matter what version of Java you're using. So you must specify these versions. How do you do this? One option is that you configure the Maven compiler plugin as a full block in your POM and specify two properties, compiler source and compiler target. Or you can define those properties inside the properties block, such as Maven compiler source and value, and Maven compiler target and the other value. Or you can pass it in the command line as well. So let's do that. Those are the quickest options. So let's do a clean again. Let's do compile and define those properties. Maven compiler source equals 1.8 and the Maven
compiler target equals 1.8. So compilation, and let's do a head again to decompiling. And now major version is 52, which is actually Maven is Java 8. So it actually makes a lot of sense now. Now, these two properties were defined by the Maven compiler plugins. If you want to know more about the properties of that specific plugin, then you should browse to the web page, the website of the plugin. And the same will go for any other Maven plugin. The Maven as a build tool chain, when an author creates a plugin, it will also generate a documentation based on all the properties that are exposed to the plugin. So it makes it very easy to find out that information. So if the author publishes the website, then just a matter of Googling it out. If not, for some reason, you still have access to the source code. If it's a, well, I hope there is a public option. And well, you can also see what the plugins will be. Now, I think that I have, no, that's the next demo. Okay, now let's go back. Here's another thing. And this is a feature that I really like from Maven, that you can invoke any plugin in a project without having to configure the plugin in the POM file. You just pass in the Maven coordinates, the GAP coordinates for the plugin, the goal that you want to invoke, and any additional parameters that might be set as properties. So for example, if you wanted to invoke the Echo Maven plugin, passing an argument of hello world to the Echo message property, this is how you would do it. You just have to pass in the whole coordinates. So if we go to the next demo, which I think is the same file right here, I have a series of commands that I can show you. Let's say the first command says, I want to compile the code and execute the sample class. Notice that I'm using the show notation, exec Java. What's going on here? Exec actually is a well-known Maven plugin. There is a subset of plugins that Maven is aware of, in which case you can use the show notation. Or if you want to use the long notation, here's another command that we can invoke. This is the equivalent command using the long notation, passing the GAP coordinates for the exec plugin. So we can do this. We can cat the first command, pass it through a shell, compiles the code, and we see hello world as the output right there. We can now cat the second command, pass it through the shell, and we should get the similar result. There we go. Hello world is the output. I have another command here with the Echo plugin configure. And in this case, we're passing a different value for the property, Echo message. So it should say something like hello world from Echo plugin and the full coordinates. So I can cat this command instead of just typing it out and execute this thing. And it works. Now, I made one mistake here because I had already something. If you never have invoked this plugin before, then it will not have been downloaded. And this is found here. So let's remove this one. Oops, should do this properly. So if I invoke this command here, what it will do is download the plugin for the first time, invoke it, and then you see the output. And the next time I invoke this command again, then I will just see the output because Maven figures, oh, you already have resolved the artifacts that are needed for this to work. And that's pretty much it. So I find this is very good because now you can invoke any plugin on a project. Maybe you want to test out something without modifying the POM file. And if it works, then you modify the POM file as needed be. Or for some other reason, you would just want to test out something like that. How are we doing so far? So good? Any questions? Please let us know. Because we're about to enter a very specific and particular place with Maven, which is dependency resolution. This is one of the areas where once we got it, we saw in the Java community, we thought, oh, great, now we are out of the dark ages. we no longer have to put in jar files in source control. And so now we can properly have coordinates to find artifacts and have something that can negotiate and resolve the dependencies, but it is not without words. So there are some issues here. And but then as long as we know what are the rules for dependency resolution, many things are possible. So the thing about dependencies is that if you define a dependency in your POM file, whether it's specifically in your POM or is a specific dependency on your parent hierarchy, these are known as direct dependencies. For any direct dependency that you have defined, those may have additional dependencies. From the point of view of your project, let's call it the consumer project, those dependencies are seen as transitive. Now, the rules for resolving direct and transitive dependencies are a little bit different. When it's a direct dependency, if we first checked on the current POM, and if it's found, that's the one that is selected, and it's going to be the last one. That's very important. And if it's not found in this POM, then it's going to ask on the next parent, where if it has it, and it goes all the way up to the super parent POM. And if it's found, then that's the one that's going to be selected. Once we have exhausted all possibilities for direct dependencies, transitive dependencies will be investigated. And transitive dependencies are resolved in how many hops you need from your current location in order to reach that dependency. So say that you have a dependency on Guava, transitive dependency because of some of the things that you have added in your dependency tree. And one path leads you 3 hops to reach Guava, and this is version 25. And another path is just 1 hop to reach the version, and that version is 21. So which one is going to win? And that is the question. Actually, a few weeks ago, I created a quest on the Maven dependency resolution, and I asked actually 14 questions, whether you wanted to resolve transitive dependencies, direct dependencies in a single POM, in a POM that contained a parent, or in a POM that also required a BOM file. And I'm going to show only 2 questions. The first one is actually the first question that came out about 2 transitive dependencies that share the same group ID and actified ID, but different version. Notice that these will be considered like a duplicate dependency. Now I ask the question, who's going to win? Is it going to be the first? Is it going to be the second? Or for any reason, this turns out to be a build error. Surprisingly, only 36% of the people that responded to this question got it right. And the answer is the last one, 28.2 GRE. This is no build error, and this is not going to be the first question. The first version. Don't believe me? If you run the dependency tree command, you'll see that Maven issues a warning saying, hold on a second, there is a duplicate here with version 27 and 28, but I will allow it. And when it resolves, you'll see that version 28 is the one that is selected. Here's another question. This is question number 5. This is regarding transitive dependencies. So both Juice and Truth have a 1 hop dependency to go to Guava, right? And each one of them had a different version of Guava in its dependency tree. So who is going to win? Is it going to be version 25 because that's the version coming from Juice? Or is it going to be version 27 because it's going to be the one from Truth? Now, if you're thinking that because on the first question, the last one wins, then you will pick, oh, 27. Or you simply say, well, Juice is the first one and both of them are the same hop. So who's going to win? It's going to be Juice. Well, it turns out the correct answer is version 25. Because in terms of transitive dependencies, the first one that is found is the one that's going to use. But then you probably say, hold on a second. Version 25 is lower than version 27. Isn't that odd? Well, let's look at that. Let's go back here and let's move into the next project. Let's go, this is called transitive 1. Let's look at the POM file. So here we have Juice first and Truth second. That means Guava 25 first and Guava 27 second. If I add temporary resolution here with dependency tree, then it should tell me that the result version of Guava should be version 25 because Juice was found first. Let's go now to another project, version transitive 2. In this case, I have the dependencies in the inverse order. Truth is first, Juice is second. Who is going to win? Let's invoke Maven dependency tree. And in this case, truth wins, so that means that Guava 27 is the chosen one. What's going on here? Well, like Robert aptly said, Maven does not look at the version at all. It only looks at the location of the dependency in the dependency tree. That means that if version 25 is closer to version 27 in the terms of how many hubs you need in order to reach that, version 25 is going to be the selected one. Now, this decision was made years ago, before semantic versioning became a thing. And this is, again, Robert saying, perhaps it's time to reevaluate this decision and add something else in a major release of Maven. It could be that in next major release of Maven, version 4, we will have a way for you to define a custom resolution strategy. It could have the default being, again, by locality, or the default could be, let's look at semantic versioning proper. We'll see. In the meantime, if you cannot wait for something to be done about this, you can apply the Maven Enforcer plugin. That will let you know if there is a conflict like this, and it can also force specific versions so that you will always have the latest one. Another thing that you can do is apply the dependency management block. You can use this block anywhere in any kind of POM. It could be a simple POM, it could be a parent, or it could be a BOM file. And what this dependency management block does is it works like a lookup table. And this particular definition is saying, look, I want to consume a version of Guava, and I'm going to say version is going to be 28. I don't know where I'm going to find it in the dependency graph, but if you do, it better be version 28. And then we have these other two dependencies that we saw before, truth and juice. We know they have the transitive dependencies in Guava. We know one of them is 25, the other is 28. If I do a dependency tree resolution in this project, the chosen version is going to be always 28.2 Jerry, because that's exactly the thing that the dependency management block is doing. It doesn't matter where in the dependency graph this transitive dependency may be, as long as there is a match for the group ID and the artifact ID, the selected version you see in the dependency management block is the one that is going to be chosen. I also said the alternative will be to configure the Enforcer plugin, which provides a series of rules for you to verify that your project has the right number of versions, that you're using the correct version of Maven, that properties and dependencies are properly configured. And one of the things that I didn't understand first, but I think that is quite fitting, is this moniker for the Maven Enforcer plugin. It's the loving iron fist of Maven. Because it will make your build crash immediately whenever it finds that something is properly corrected. And this is exactly what you want. You want to detect this error earlier before kicking in expensive build on CI and just to make it have it fail for some unknown reason. You want to fail fast, fix the error as soon as you can. I also recently asked a question. 286 people responded who applies the Maven Enforcer plugin on the projects. And that means that 346 people actually use Maven, the ones that responded at least for this poll, so very scientific, I know. And that's about 35% of the people that use Maven apply the Maven Enforcer plugin. The rest either don't use it or have no clue what this plugin does or what it is. Now, this is something that needs to be corrected. Because trust me, the behavior provided by this plugin is something that personally I consider should be part of core. And I'm hopeful that some of the behavior exposed by this plugin can be added to the core Maven in a major release. We'll see if that happens. If there are many of you out there that consume this behavior and find it so useful, then engage in a conversation with the Maven team. And if you have the times and the cycle and the skills, perhaps provide a patch and help them get this thing going so that we can have a much better support in the future release. Here's other things that happened in this particular quest. This is actually the distribution of the answers. As I said, I have 14 answers. Only 7 people out of 509 have all correct answers. The median is around 8 with a standard deviation. No, I didn't calculate the standard deviation, but the median and the average is 8. So most people have kind of an idea how maybe dependency resolution works, and some of them will have no clue what's going on. Here is defined in the 3 different sections. The first section is about just a single project. Section 2 is when you add a parent pump into the mix. And section 3 is when you add a BOM file into the mix. And you can see if question number 1 and question 5 are quite low. These are the questions that I show: duplicate dependencies and transitive dependencies. This is how each section looks like in terms of the median, the average, and the standard deviation. You can see section number 3, when BOMs get used, that the results were not really good. At least 50% of the people say, I'm fine with BOMs, I can't understand BOMs. The other 50 people have no clue. And finally, the last graph here shows you how many people chose build error as an option. And the first question, you can see almost 36% of the people, almost the same amount of people that chose the right answer, also chose this wrong answer. These questions never created an error. So this was only an option for those that didn't know what's going on, or generally thought that there was an error. And you can see that besides that, when you go to the last number of questions, when the BOM files are related, that the percentage of errors increase. So that means that people have no notion of BOM files, or do not understand. The rules may not be clear. The documentation may not be clear. So there's something that can be done for the Maven community to make things better. If you're still facing issues with dependency resolution, I strongly recommend you to have a look at this presentation by Robert and Ray. The link that you find here on the slide, it's a link to the video and to the slides used by Robert and Ray. They have actually presented this a couple of times. And it's a really interesting session on the many different things that can go wrong when you want to configure dependency resolution. The Maven Enforcer plugin makes an appearance a couple of times, but it's not the only tool that you have at your disposal in order to make things better when trying to resolve dependencies. So far, so good? All right, so let's go to the next one. And this one is quite a funny one. Do not invoke Maven cleanstall. What's going on here? Well, let me tell you about the first rule of Maven Clavis, which is you do not invoke Maven cleanstall. Now, the second rule is actually, really, no, trust me, you do not invoke Maven cleanstall. Why? Because the third rule of Maven Clavis is you should invoke Maven Verify instead. Now, if you don't trust Tyler Durden, then please trust me, because Maven Verify will bring rainbows to your build. Now, what's going on here? What happens is Maven cleanstall is a cargo code from the times of Maven 2. And I learned this as well when I also got into Maven. What happened is that when Maven 2 was doing the rounds in the early thousands, you did not have support for building multiple projects with it. At another point in time, a third-party plugin called the Reactor Maven plugin was created, and this will allow you to have big multi-project builds. Now, because it was a third-party plugin, it gave you some capabilities, but it did not have really good integration with other plugins. Because of this, you had to do a clean on your build to make sure that you did not have any intermediate results or something on any stale or outdated artifacts. Then do an install on the Maven repository, your local one, because the other plugins will find those artifacts needed to do their job. Now, because this behavior, the Reactor plugin, was so good, it was later added to Maven 3 as part of the core behavior. And because of this, the benefits of the Reactor get immediately made available to everybody else, to every plugin. That means that invoking clean install is no longer a requirement. It's something that you might do, but only if you really need to publish artifacts to a repository. Most of the times, it's good enough to just invoke Maven verify. What you want to do is just check that your project is building, run the test, even generate the jars, the Java doc, or anything that belongs to the to the check phase as well. So verify is one of the goals. It's a lifecycle phase. It's not a goal. And because most people like myself move from Maven 2 to Maven 3 without really looking what is new, then this cargo code of, oh, just call clean install and that works, it actually permeates. But when you do, you're actually telling Maven to do more work that is needed. Every time that you also invoke clean, then you are making your builds run more stuff, run slower because you're telling it to do things that it should not be doing, but also you're deleting those intermediate results that will hinder incremental builds. And that's something that if you really want to have better and faster builds, then it's okay. It's better if you use incremental builds. All right. Here's another good session by Robert. The link to the videos right there. This was presented at DevOps Belgium 2019, so last year. And what he shows here is he gives you more reasons why Maven clean install is not a good idea. And invoking Maven verify may be better in most occasions. It also has a very funny extension called the Maven clean install extension that will warn you when you didn't have to use Maven clean install and will fail the build the second time you shouldn't have invoked clean install. So that's kind of like an early reminder of you better be using verify. Now, the next feature that I want to show is something that I really like coming from the Gradle build tool, which is invoking a subset of the Maven reactor. In Gradle, you can invoke any goal on any project and it will build all the dependencies that are needed, and you only need to specify that particular goal, not everything else. In Maven, we have something similar. It's called the -am and -pl flags. AM stands for also make, and PL stands for project list. So this is what's going on. I call this partial execution. I actually don't know what the actual term, if it actually has one, and but let's go with this one. So when you have a multi-project build, what Maven does is build everything inside what is known as a reactor. You remember that reactor Maven plugin that I was telling you about in Maven 2? Well, now again, it's core behavior in Maven 3. Now the reactor executes all goals for all projects. And say that you have a project with a big multi-build, 50 or 100 modules. You make a change in one of them that has 5 other dependencies, and you only want to build that small subset. That's actually your project, 5 dependencies, and the root build, that's about 7 projects. You want to invoke those goals in only those 7 projects. You don't want to invoke those goals in the all 50 or 100 projects. So what you do, the first thing you do, you specify PL and the path to the project or projects that you want to be built. And secondly, you specify AM so that for any other dependency found in the projects, in the project path, will also be made. It will be part of the reactor. So let's look at this demo. I'm gonna switch to the terminal, and let's do this partial too. And let's see what we have here. Let's look at the build project first. So we have a root project here with 4 subprojects. The root says, this is a multi-module build that contains 4 modules. Fine, nothing fancy. Let's look at the first project. It only contains the gap properties to its parent, inherits the definitions like group ID and version from its parent. So we only need to define artifact ID. Again, there could be more information here. We're just going for the minimal settings. Let's look at project 2. Actually, sorry, that was the wrong number. Project 2 has similar settings, but this one has a dependency on a sibling project, project 1. Then we look at project 3. This one, similar to project 2, has a dependency on project 2. And finally, project 4, we're back to the simple things. It has no dependencies. If we look at the sources, let's do a clean just in case, because I don't want to show more stuff. We look at the sources. Project 1 has one Java source. Project 2 has another Java source. Project T has something that appears to be a main class. And project 4 has another thing. So out of the bat, I can say at this position, which is the root, right? I can do as I did, clean and compile. And this will invoke the clean and compile lifecycle phases on all projects, including the root. So the reactor tells me there are 5 projects here. But if I only want to do it for, let's say, project 2, this is what happens. I can say -am -pl column project 2. So column project, that's the path to the module that I want. And then do this. And, oh, sorry, that was a P, not an L. There we go. And then the reactor actually says it's actually 3 projects now. Well, that's pretty good. Here's another thing. Let's look at project 3. This one has, oh, come on. This has a main class like this, right? So we know from the earlier minutes of this session that we can invoke any plugin on any project. So we could invoke exec.java on this project, project 3. And we can define properties such as the main class for this thing also on the command line. So what if I go back here and simply say, let's do project 3. And I want to do clean and compile and exec.java. And let's make sure that the main class that I want is acme main. Actually, that is a dot. So this should compile the dependencies, project 1 and project 2, project 3, and execute project 3, right? This is my expectation. Let's see what happens. Yeah, the reactor says I have 4 projects, but we got an exception. What's going on? It says it cannot find acme main on, hold on a second, where is this thing? It's on the build project. What's going on here? Well, we have a problem here. What's going on? The thing is that you remember I said the reactor will invoke all goals on all projects. That means if you want to run exec.java on project 3, it has to be valid on all its dependencies and the root as well. Because we only specify exec.java for project 3, there will be a failure on the other ones. So in order for this to work, we need to make sure that the plugin and the goals that you want to invoke are also available in everybody else. And for the time being, the moment that the way that we can do this is by adding a plugin management block on the parent or parents, because you may have different parents in your whole multi-project build, so that the same plugins that you want to invoke are available. By default, make sure that this plugin is disabled. You might need to configure additional properties to fake out some values. And when you want to invoke it for the specific project, it should work. So what do I mean by this? Let's go back to the demo and have another working demo here. This is partial number 2. And let's see what is the difference. Let me do a clean just to make sure that nothing is up my sleeves. Then we have 4 projects and the root and the same source files as before. What is different is the build configuration. The root, we define 2 properties, the sec skip and sec main class. These are defined by the exec.java plugin. We define in plugin management block that we will apply exec Maven plugin. And we automatically apply it. That means that for every child that inherits from this parent, they will always have the exec Maven plugin available. And because we define these 2 properties, the exec Maven plugin will always be disabled by default. And it will have some non-empty value, even though this is now not a valid class name for this project. So we have something that makes the plugin configuration pass, but it will do nothing. If we look at project 1, remains the same. Project 2, the same. Project 4, the same. What will be different is project 3, because this is the one that has the main class. This one, we redefine the value for Acme main. And we apply the plugin. We also apply it with skip here. I think we could have added the exec skip property here instead of configuring the plugin, but this will be the long way to do it. Now, every project now in this build has the exec main plugin applied to it. So I can happily say now maven-am-pl colon project 3, clean, compile. Actually, I don't need clean because I did it before. So we just need compile and exec Java. Oh, again, I'm missing a P. There we go. So the reactor says 3 projects plus the root. Execute. Maven on build says nothing because we're skipping. Then builds project 2, skipped. Then comes to project 3 and executes. We can pass an argument here with exec args, and let's say hello virtual jog. And if that did things correctly, then we should see hello virtual jog right there. So the parameters are being passed. So things are working properly. This is how you make things work. So far, so good? I hope so. All right. Here's another one. Aggregating pumps. This is another cool feature. Now, you might have seen aggregating pumps before. Actually, we just saw one. Our root build is an aggregating pump that also happens to be a parent pump. But that is a coincidence by design. But aggregating pumps do not have to be parent pumps and vice versa. Why would you like to have an aggregating pump that is not a parent pump? Here's one scenario that is actually quite true. Say you have a project that has a dependency on, let's pick out now on common slang. And you found there is a bug. And you need and you have the time and the passion and you fix it. But before committing it, you have to figure out if it's working correctly, right? And with your project, not because it works perfectly well with common slang. So without an aggregating pump, this is the life cycle you have to do. This is the workflow. Fix the bug in this dependency, common slang, push it to a local repository or even push it to a remote nexus. Then go to your project, define the dependency, the new version, consume it, run the test. If it works, perfect. If it doesn't, you go back to the project, try to fix it and come back and you do this until the error is fixed. Now, every time you do this, you're publishing artifacts and you might get in trouble with either it's the space, maybe it's time, maybe you forgot to publish the fix and then you run the test because you went in a coffee in between and then things are not working and you lose 2 hours just for, the artifact was not published. So how can we make things better? If you put an aggregating pump in between and say module 1 is your project, which could be multi-project build as well, and the other module is common slang, and now these 2 things that were separated before now belong to the same reactor. And because now you know that you can override properties anytime you want to, you can invoke plugins anywhere you want to, and you can invoke a subset of a reactor using the -am-pl flags. Now this whole reactor makes things much easier. Here's one example that I'm telling you about. So say base is your project and bomb is common slang. This is how the aggregating pump would look like. And your base project or whatever it is and common slang, they will still inherit from the original parent. You don't change that. And things just work. We're going to skip this one. Finally, bomb files. So BOM files are actually quite like a recent concept. They more have like 3 or 4 years where it actually got used in anger by developers. And what BOM means is a bill of materials. It's basically a recipe of dependencies that should come together. You may have seen BOM files if you are used to working with a Spring Boot, Micronaut, Quarkus, Helidon, or any other microservice frameworks. I think that Netty also provides BOMs, and other big projects out there also are now providing BOM files. The idea is in your project, whether again it's a parent or a POM, you consume this project, this BOM file. Now, here's a definition of a BOM file. Inside the dependency management block, you put a bunch of dependencies that come together. This is a very trivial example that only contains one dependency. So basically, it's just a silly BOM file, but it works for example reasons. And when you consume this, you do it in this way. You define a dependency management block, and inside that, you define the dependency to the BOM file that you want to configure with 2 additional settings, and these 2 are very, very important. First, you must set the scope to import. How many scopes do we have in Maven? 6. We have compile, runtime, test, system, provided. Don't even remember that system exists. Please don't. That's one thing that is come from the past. And finally, input. And the next thing that you need to do is the type of the dependency. The type must be POM, because by default, Maven resolves dependencies to be jars. So it uses the gap coordinates to find a jar file, something that has the jar extension. So the type property here maps to the file extension. So if you do not set it to POM, Maven will try to resolve a jar file that does not exist, and of course, nothing will work. So make sure that you have both the scope and the type correctly. And once you do, then you can define dependencies to things that are combined, that are coming from the BOM file. As we saw, this sample BOM file is providing Guava. So I just happily have to add the group ID and the version ID, the group ID and the artifact ID, and skip the version. Why? Because that version is going to come from the BOM file, which gets loaded in the dependency management block, which we saw before is kind of what you use in order to resolve the transitive dependencies. If you want, you can override the scope for Guava. By default, it's going to be compiled if you never define a scope. The BOM file might define a scope, but you can also override it, and up you go. So it's up to you. So this is basically what I have for you today. And these are the features, some of the features that I rediscovered after so long spending time with other build tools. And I have found that these properties, these plugins, these features let you use Maven in a way that you can have faster builds, you can have reproducible builds, you can have, in some cases, incremental builds as well. Now, not everything is perfect, of course. Maven, as many other things out there, is an open source project that thrives and lives by the community. If you consume Maven, if you use Maven, if you find a problem, please report a ticket. Come or swing by to the Maven list and let the people know, hey, is this the correct way to use this feature? I found this particular problem. Is this actually a problem? Engage in a conversation, and perhaps turns out to be a missing feature. Perhaps turns out to be a bug. And then you and the team or someone else can help fix out this particular problem so that we all can have a much better experience and a much better tool. So I mentioned earlier, I'm employed by Oracle. So if I said anything regarding Oracle and its properties, you happen to make a purchase, then don't believe anything that I said about Oracle, all right? You're safe. And with this, I'll say, well, thank you very much. And I guess now it's time to go to the questions if you have any.
Cool. So before we get started with questions, just a little bit of housekeeping. If you guys are enjoying the VJug session that you're seeing today, we would really appreciate if you would hit subscribe on our YouTube channel so that you could get alerted when new videos are posted. And back to housekeeping, we have had people ask if you're going to share your slides or the links so that they can find those reference material. We will have this posted live, but we also want to make sure that they have an opportunity to click on your links.
Yes, of course. Yeah, the slides will be made available to everybody.
Cool, cool, cool. So I don't know if I'm opening a can of worms here, but someone did want to know why Maven over Gradle. So you can choose to answer this or not answer this. It is up to you, but I did feel like putting you on the spot because you are my friend.
Well, so for those that know me, I've been promoting Gradle for 10 years now. I actually even worked for the company for half a year last year. So I do have some feelings and reasons where I would prefer to use one tool over the other. But it's also true that I started my development career with nothing. I mean, I started back in '95 where we have even just make and end. So I have seen the pain of growing with different build tools and how our industry has gone through. I would have to say that, like many things, the choice is up to you. It all depends on what you want to do. If you're already using Maven, if the features that I showed you today and other features that you found out there in the web are good enough for you, there's no point in changing. You will change only if you have a lot of pain and the tool that you're currently using does not give you the answers. It's not because you hate XML. It's not because someone in your team likes Kotlin or Groovy. It's not because there is a shiny new feature that the other tool have. No, it should be because you have pain. It's because the tool is not good enough for what you need to do or what you want to do. There are reasons why I would prefer to use Gradle for many of my projects. It's just because I have a very specific way of how I build my projects. But if I'm working with a team and the team has more experience with Maven, 100% of times I will just go with Maven, because I will not submit my team to my own personal whims and say, oh, I like this thing, and then everybody else has to suffer, everyone has to learn. That's not the way that things work. If your builds are very slow, you might consider giving Gradle a chance, but be sure that it's going to give also a couple of things that are painful. There's a learning process, there's a different tooling that is involved. It's, again, it's not an easy answer. What I can say is give it a try. What do you have to lose? It's a couple of hours. If it doesn't work, then stick with what you have. If it's really, really painful, then you and your team have to invest more to figure out if that tool or there's another one that gives you the answers.
That was a very good and diplomatic answer, my friend. So again, caveat, I am not a technical person, but we had a question and it says Maven 4, when and what inside? So I'm assuming they want to know if you have any insider tips as to what's coming on the next release.
There is a roadmap published on the Maven website. And if it's not, I saw it 2 years ago for sure. Well, things that may come in Maven 4. So one of the things that actually I'm excited that is actually coming in Maven 3.7, so we don't have to wait for a major version. This is something that Robert already showed. There is the Maven wrapper that is very similar to the feature that we have in Gradle called the Gradle wrapper that allows you to bootstrap Maven within itself for selling it like this way. So you don't have to tell someone from IT, all right, would you configure that particular version of Maven on CI because I want to run it? No. You put the Maven wrapper in your project, and when you run on CI, it downloads a specific Maven version of Maven for you, and everything works. So this is one step forward into reproducible builds. This is coming in the next version of Maven 3.7. The current POM file that you have defines how you consume the project as a consumer, but also how you build the project. Now, the same file that contains all the instruction gets sent to the consumers. It makes no sense for those consumers to see how you build. Actually, there may be some things that you want to keep secret. So the next thing that is coming in 3.7 is something known as the consumer POM. So only what is needed for a consumer to see what you need from your artifacts is going to be put there. But your build instructions, the POM that you publish, will not contain this build extension, so that's quite good. Again, less information, more security, and less data that needs to travel across the wire. The feature that I showed about -am -pl, so that you have to configure the plugin in every project so that the goals are available. It may be the case that in Maven 4, I think I saw in the roadmap, that this feature would make it be easier so that you do not have to configure the plugin in everybody for this to work. You only configure it in the project that actually requires that specific configuration.
Cool, cool. So we have a question from Bruce, and he wants to know, does Maven have a feature or plugin to build multi-release jar files?
And the answer is yes, and I can see that Robert just replied on the Slack channel.
Boom.
With a link. Robert is the PMC chair of Maven.
So he's someone we should know.
Yes, if you are into Maven, then you should follow Robert on Twitter. You should follow the mailing list, and you should interact with him on any event like this one, like BJOG, or any other event that you have your chance to talk to him. He's a great person.
We did have a general question in the YouTube chat, and it was, what is your favorite language to program in?
Most of the times I program in Java, but I'm also a member of the Groovy development team. So if I'm not working in Java, I just do Groovy.
All right, guys, last call for questions. Go ahead, hit us up in the Slack, and we'll give it one more second. Is there anything anywhere else that you'd like to let us know about while we wait to see what kind of questions come in?
There is actually a call for action in the Maven project to help with contributions. Let me remind you that Maven, being a full Apache project, means that all the work that is going on for the project is done by volunteers. There's not a single entity that dominates the roadmap for the project. So everybody has a chance to voice their opinions and to figure out where this project could go. This being the case, the Maven team is distributed across the world and definitely need all the help that we can give them. In the GitHub issue tracker for the Maven project, there is a tag called Up for Grabs. These are issues that have been deemed by the team easily and readily available for anybody to tackle on. So if you want to get started with open source and if you want to help Maven, then have a look at those issues and see if you can fix one of those, and that will be very, very helpful.
Thank you, sir. I have a question that says, should I include wrapper in my Git repo?
You should include the wrapper. Yes, there is a project out there, the Maven wrapper from Takari, and that is the current version that you can have to use the wrapper. And as I said, coming in Maven 3.7, there will be an official version of the wrapper coming also along with Maven.
So I think this is another poke question from our friend Oleg. Wants to know if you started using Kotlin yet, and it sounds like it can help you with your Maven problems, and it's a great language, don't you think?
No. So yes, I gave it a try to Kotlin, and it's a language that didn't add anything to the things that I like to use. It's not my thing. I know there is a lot of buzz and a lot of hype about the language that other people pick it up and say, oh, this is great. Well, it's good for them if they can actually make something with it and they're happy. Of course, it's something that can give you answers. It's just not for me. And with Maven, well, I mean, he's thinking about DSL. For the Maven, there is only one true thing, and that is XML. There is one other thing called Polyglot Maven that allows you to use Groovy, Ruby, maybe JavaScript or something else instead of XML. Is XML going to go away with Maven 4? Not a chance.
Okay, and if you are looking at the Slack, if you could read that last question, I'm not sure exactly how to say it, and I've already embarrassed myself enough today.
There's a documentation on how to use the Maven AMPL. No, Not really, besides what I showed you today and what you can see on the help and what you can see on the website. There's bound to be a couple of books out there on Maven, although I have no clue if they actually discuss these features or not.
Okay, so we are at the top of the hour, and I'm going to read one more question. It says, does Maven integrate with Graal to build native binaries?
So actually, this, what we rephrase it, is there a plugin that allows you to use Graal so that you can build native libraries with Maven and Graal? The answer is yes. Yes, there is one. I think you can even also use JLink as well. So Maven has good support for all the tools coming from the JDK.
Cool.
And
Well,
Ray just posted on the Slack channel the link to the integration with Graal and Maven. There we go. Thanks, Ray.
awesome. Well, since we are hitting our hour mark, if there is anything else you'd like to leave our viewers with, if not, we can go ahead and sign off and tell people to look towards our meetup page for upcoming sessions that are happening in the next couple weeks.
Right. Thank you very much, Lori, Oleg, and everybody else for listening. You can reach me on the BJUG Slack, and you can also reach me on Twitter anytime you want. If you have any questions on Maven and open source in general, Java, you name it. I'm just happy to share the knowledge.
Awesome. Well, thank you everyone for joining us today. We hope you have a good rest of your day, whether it's morning, noon, or night. And again, join us back on VJUG in the next couple weeks. Y'all have a good one.
Okay. Goodbye, everybody.